Hello, I'm Brenton, one of our MCAT tutors here at Inspira Advantage, where we help students get into med school and other professional programs. Today, we are going to demystify 3 incredibly important pathways you need to know for the MCAT: glycogenesis, glycogenolysis, and gluconeogenesis. Let's start by getting these names straight and figuring out exactly what they mean by looking at the root words. All we need to know are what the prefixes and suffixes mean. Let's start with the prefix glyco. This refers to glycogen, whereas the prefix gluco refers to glucose. It's important not to mix these up, so I'll put them on screen here. Additionally, we want to know what the suffixes mean. Genesis means creating, while lysis means breaking. Now, when we build these words together, we get a picture of what the different processes are doing. Glycogenesis is glycogen. Now, when we build these words together, we get a picture of what these different processes are doing. Glycogenesis is glyco from glycogen and genesis from genesis, or creating. Okay, so this means that we are creating glycogen. In other words, we're building glycogen. To build glycogen, we need to know about 2 very important enzymes: glycogen synthase and branching enzymes. These enzymes are only found in the liver and muscle cells. Glycogen synthase is going to create alpha-1,4 bonds, whereas branching enzyme is going to create alpha-1,6 bonds. So what does this look like? Well, glycogen synthase is going to create long strands, but branching enzymes is going to turn these strands into more of a 2D glucose glycogen mat. We'll draw out what this looks like here. So as you may have noticed, there's been this big picture of glucose just sitting up in the corner here. We're going to use this as a model to connect and build glycogen will look like. So first, let me label what these carbons are. There's carbon 1, 2, 3, 4, 5, and carbon 6. Okay, so now we've got those labeled. Let's start connecting things. We said that glycogen synthase is going to bind alpha-1,4. Well, alpha, we know, means below, and 1,4 is just between the first and the fourth carbon. So we're going to have a bond just like this. So what's it look like if we daisy chain a bunch of these together, essentially? As you see, we begin to get and grow a very long chain. But this isn't an efficient way to store glucose. This is just one directional. We want to branch out this chain. So that's exactly what branching enzyme does. And we said that branching enzyme forms alpha-1,6 bonds. So again, alpha-1,6. This means that we're going from that first carbon down to the 6th. So let's make room here. We're going to bond from this top first carbon down to carbon 6. And the way this works, we're going to end up removing the alcohol group right there and adding this branch. So as you can see, this process will continue until we end up with 2-directional growth. So now let's think about, when would we want this to happen? Well, if we have a lot of excess glucose or energy in the blood, this is going to cause glycogenesis, the production of new glycogen for storage. So that way you can use this later. It's great to store glycogen for later use, and when we want to use it, we need to break it back down or lyse it, thus glycogenolysis. Again, we need 2 specific enzymes to do this. They are glycogen phosphorylase and the creatively named debranching enzyme. And these are much like their counterparts when we were doing glycogenesis. Glycogen phosphorylase is going to break those alpha-1,4 bonds, and debranching enzyme is going to break the alpha-1,6 bonds. So let's pretend we have glycogen phosphorylase coming through. So this is going to chop up our alpha-1,4 bonds. So boom, that'll get cut off. We'll have a free glucose. Another one, boom, we'll cut that off. We've got free glucose. You can begin to see where these glucoses are going to come from. Okay. Well, how about the debranching enzyme? Well, we said debranching enzyme is going to break those alpha-1,6 bonds. We only drew one of these, and that's right here. So debranching enzyme will come through, cut that, allow us to remove a second chain. And once we have this second chain, how can we break apart these two bound glucoses? Well, again, we take glycogen phosphorylase to break that alpha-1,4 and separate out our sugars. We can then take these sugars and throw them into glycolysis to get energy out of them. The final pathway we want to talk about today is gluconeogenesis, or the building of new glucose molecules. This will happen when glucose levels in the blood are low. Gluconeogenesis is essentially the opposite of glycolysis. It uses all of the same enzymes except for the 3 irreversible steps, which are bypassed by different enzymes. If we take a look at the 3 irreversible enzymes that we talked about in the previous video, we see that they're in blue here: hexokinase, phosphofructokinase, and pyruvate kinase. Well, let's clean this up. If we want to run this reaction in reverse, let's start down at getting past that first irreversible enzyme, pyruvate kinase. It actually takes 2 different enzymes to get by pyruvate kinase. First, we have pyruvate carboxylase, and then this tricky little enzyme called PEP-CK. Both of these are needed to bypass that irreversible PK step, and these enzymes are activated by acetyl-CoA, glucagon, and cortisol. The other important enzyme to bypass is PFK. This is a little bit more simple, where it's just bypassed by an enzyme called fructose 1,6-bisphosphatase. Notice that this is really similar to the product being made by PFK. PFK makes fructose 1,6-bisphosphate. Well, if we want to run that in reverse, you need to remove that phosphate, thus the phosphatase. This enzyme is activated by ATP and glucagon, and it is inhibited by AMP and insulin. Finally, hexokinase is the last enzyme we need to bypass, and it is bypassed by glucose 6-phosphatase. Again, similar naming pattern as we saw with PFK. It's just the product, but phosphatase. There's a lot of information you need to know about glycogenesis, glycogenolysis, as well as gluconeogenesis for the MCAT. In future videos, we will talk more about hormonal control, as well as how the body's energy balance impacts these processes. Thank you so much for watching our video on glycogenolysis, glycogenesis, and gluconeogenesis, and I will see you next time.